Hi 8th grade, this is Ms. B here with lesson 3.8, and today we are dilating polygons according to a scale factor. So this is the last transformation, the fourth transformation that we'll be learning. So a dilation stretches or shrinks an original figure. We use a scale factor to either enlarge or reduce that given figure. So notice as I'm making this purple rectangle larger and smaller, the angle measures are still staying the same. What's special about a dilation is that the side lengths stay in proportion to one another. So let's take a look at some examples where that happens. A proportion is when the relationship, in this case when we're talking about dilations, we're talking about the side lengths that are equal ratios to one another. So a scale factor is what we use in a dilation to enlarge or reduce a figure. So when our scale factor is at 1, our two images are going to look exactly the same. The side lengths are going to be the same and the angles are going to be the same. So if you notice, the red and blue triangle that are overlapping are dilated by a scale factor of 1, so nothing in the image has actually changed. If we were to make the scale factor greater than 1, you'll notice that the image begins to get larger. So whenever your scale factor is greater than 1, this enlarges our figure. So let's go back to 1 where two triangles would be the same size. What do you think would happen if we were to have a scale factor that is less than 1? Our image would get smaller by that scale factor. So let's talk a little bit more about ratios and proportions. If we dilate triangle ABC by a scale factor of 2, notice what's happened to the side lengths from AC to its corresponding side, A prime, C prime. It's doubled in size. The same thing happens with segment CB and its corresponding side, C prime, B prime. To get from a side length of 4 to 8, we must multiply by 2. So take a moment to write these two definitions on your handout for today. So the three other transformations that we've covered so far, which are rotations when we turn an image, that's messy, a rotation when we turn an image in the coordinate plane, a translation when we slide an image in the coordinate plane up and down, left and right, and we have a reflection, which is when you flip an image either over the x-axis or over the y-axis. The three transformations that we've been practicing over the past 2 weeks, we end up with the same exact shape, the same size, and the same angles. The only thing that's changed with this type of transformation is where it's actually located on your graph. So today's transformation, which is a dilation, produces figures that are similar to one another. So similar figures are still the same shape, they have the same angle measure, but what's key about dilations is that their sides are proportional. So obviously when we're making an image bigger or smaller, the side lengths are going to change, but they don't change by different amounts. Each side changes by the same amount so that it remains proportional. So no matter what side lengths we have for our triangle, when we are dilating by a scale factor of 2, the side lengths are still in proportion to one another. They grow by the same amount. Or similarly, if we are shrinking or reducing our image, then they would get smaller by the same amount. So let's focus now on what happens to each ordered pair or each point of our image and our pre-image when we perform a dilation. So let's look at a scale factor of 2. So let's identify where A, B, and C are, and notice what happens to A prime, B prime, and C prime. So point A on our graph is at 3, 6. Point B is at 6, 2. And point C is at 6, 6. Take a moment to identify where A prime, B prime, and C prime are. So notice A prime is at 6, 12. B prime is at 12, 4. And C prime is at 12, 12. So the way that we perform a dilation is by multiplying each X and Y value by our given scale factor. In this case, it's 2. So 3 times 2 gives us 6 for X, and 6 times 2 gives us a 12 for Y. So we've also done the same with B and C to get to the coordinates of our image. So the 3 ways that you would see a dilation is in word form, where it would specifically tell you to dilate by a scale factor of a given number. In this case, we're dilating by a scale factor of 3, so we know our image is going to get larger since that number is greater than 1. In the second word form, we are dilating by a scale factor of 1/3, so that image would get smaller since that number is less than 1. You can also have this capital D, and the smaller number that's with it is the scale factor. And we have our coordinate rule, which is what we just looked at, that you are multiplying each X and each Y in your coordinate for your pre-image to get to your new image. So take a moment to practice on page 1 by multiplying each point by the given scale factor. So in part A, if point A is at 9, 2 and we are dilating by a scale factor of 7, each X and Y value must be multiplied by 7. So that leaves us at 63, 14 for A prime. In part B, we are dilating point B, which is at 12, 4, by a scale factor of 1/2. So each X and Y value gets multiplied by 1/2. 1/2 of 12 gives us 6, and 1/2 of 4 gives us 2. So B prime is at the point 6, 2. Take a moment to dilate the coordinates for each of the 3 triangles in part D, E, and F. Unpause this video for the solutions. You can check your answers with the solutions provided. Be sure to label your primes. So if you're identifying A, must correspond with A prime, B with B prime, and C with C prime. That concludes our mini lesson for dilations. So now it's your turn to actually practice how to perform some dilations. And when you complete station 1, you are continuing to practice rotations. Whatever is not done for classwork must be completed for homework due on Monday. Have a great weekend.